Hello class, this is Mr. D'Amico with another math lesson for you. Today we are going to be talking about solving systems of equations involving three variables. We've already had experience in solving systems of equations with two variables, but today we're going to be talking about systems of equations involving three variables. And you can see by the clock it is time to begin our lesson. The goal for today is for us to solve a system of equations with three variables, and that means we are going to have three different equations, which is one more than we've had before. So let's get ready and let's get after it. Here's what an example looks like. We have three different equations with three variables, x, y, and z. And the first thing I like to do, since there is an extra equation, I like to label my equations. And I'm going to do that here for you because I am going to be referring to the equations by their name. I'm going to call these equations A, B, and C. So if you could do the same, that would make things very helpful. To accomplish our goal, I'm going to break it up into three parts. The first part of our goal is we would like to eliminate one of the variables, and when we do this, this will result in having just two variables and two equations. So we're going to have a system with just two variables and two equations, and we've had experience in solving that before. So it's going to take one step for us to get this problem down to something that we've seen before, and then we can solve it from there. So let's try to do that right now. What variable should I eliminate? That is usually what we want to look for next, and you can see I highlighted the y in equation A, that's a plus y, and the negative y in equation B. I can add those two equations A and B together right now, and the y's will eliminate, and that will leave me with just x and z left over. And if you look at equation C, there's an x and a z already in there by themselves. So that would be a good way to start. Take equation A and equation B and add them together since they're opposite coefficients to eliminate the y, leaving me with x plus z equals 6. Now I put a star by that equation. That is the equation that has two variables. I want to do this again and get another equation that has two variables, and then we'll accomplish the first part of our goal. If I look at equation C, like I said earlier, it already has the x and the z in it, so I really don't have to eliminate the y because there is no y in equation C. I can just recopy that. That's my second starred equation. I like to put stars by them because that tells me that those are the two equations that I am going to solve now like I have before, since I have two equations and two variables. So part two of my goal is to solve this system of the starred equations. And again, I eliminated one of the variables, hoping to get to this point where I would have just two equations with two variables, which I have. Put stars by them to remind me that I want to solve them next. So I am going to solve those two next. Now I have an x and a z. It looks like it's a positive 1 for both x's. So I think I'm going to multiply the top starred equation by -1 to give me a negative x minus z equals -6. Then I can add those two equations together to eliminate the x, and I'm left with z equals 4. Part 3 of my goal, the final part, is to take that value and to substitute it to find the remaining values. In this problem specifically, I need to find x and y since I found z. And I think what I will do next is I will take that z equals 4, and I'm going to use equation B and substitute the 4 in for z. And then if I work that out, negative y plus 4 equals 3. I'm going to do some algebra and get down to y equals 1. So then all I need to do is find x. If I take equation A and substitute in 1 for y, I can get x plus 1 equals 3. And finally, I will get x equals 2. So the solution to this system is x equals 2, y equals 1, and z equals 4. We've just solved our first system with 3 equations. Congratulations. Here is our second equation. So first thing I would like to do again is to label my equations A, B, and C. And now I want to look for which variable looks the easiest to eliminate. If I start by looking at the x's, let's see, I have a 2, I have a -3, and I have a -5. Now, that doesn't look the easiest variable to eliminate because I would have to multiply each equation to eliminate the x's. So I'm not going to do that. If I look at the y's, I have a +4, +5, and +3. Again, I would have to multiply 2 different times each equation by a different number, and I'm going to go for the z's because I don't think that's the easiest one yet. If I look at the z's, there's a -z. And if I look at my other z's, I have a +2 and a -5. So if I multiplied equation C by a number, I could get it to be the opposite of 2z. I could get it to be a -2z, and I could get it to be the opposite of -5z, a +5z. So I'm going to eliminate the z's because that looks like it's the easiest place to start. So let's take equation A, and let's take equation C, and I'm going to eliminate the z's like I said. So I think I'm going to multiply the bottom equation, equation C, by, how about -5? And once I do that, I'll have 25x minus 15y plus 5z equals 85. Then I'm just going to recopy equation A below so it's lined up nicely. And then I'm ready to eliminate the z's by adding them together. So that's going to give me my first start equation with just 2 variables, 27x minus 11y equals 103. Put a little star by it. And then I am going to eliminate the z again. I'm going to erase this, but we will bring the start equation back shortly once we have enough room. So I'm going to keep equation C there, but now I'm going to go with equation B. And I'm going to eliminate the z's again. So it looks like this time I have a 2z and a -z. So if I multiply the equation C, the bottom one there, by +2, that's going to give me -10x plus 6y minus 2z equals -34. And then I'm just going to recopy equation B again. And then I'm going to add them together. This time I'm going to have my second start equation, -13x plus 11y equals -61. So the z's are eliminated. I now have 2 start equations, and I am about to take those 2 start equations and solve that system, which only has 2 variables. Now, if you look at those 2, I am very, very lucky that the y's are already opposite coefficients. I don't have to multiply anything. That won't always happen. Sometimes you'll have to multiply one of the equations to get opposite coefficients. Sometimes, unfortunately, you'll have to multiply both equations to get opposite coefficients. That's not the case here. I can just add them together. 14x equals 42, which means x equals 3. Now I can take that x and substitute for known values. Now for this one, if I try to substitute in one of the original equations up here, you can see that if I substituted in, let's say, take equation C for example, if I substituted in 3 for x, I would still have a y and a z, and I wouldn't be able to solve for those because I don't know what y and z is yet. So what I'm going to do is I'm going to take x equals 3, and I can substitute it into this x here of this start equation, or I could substitute into this x here of this start equation. And I'm going to use the top one. So I'm going to go 27 times 3 minus 11y equals 103. And I'm going to go ahead and solve for y like so. And my final answer is going to be y equals -2. Now I have 2 variables, and this time I can choose whatever equation A, B, or C looks the simplest to me. I am going to take equation C, and I'm going to substitute in 3 for x, -2 for y, and solve for z this time, which is the last variable. So if I work out my algebra, I'm going to get negative z equals 4, but we all know that that means that z equals negative 4. So my final answers are x equals 3, y equals negative 2, and z equals negative 4. There you have it. There are 2 examples of systems of equations involving 3 variables. Please try the backside now. This is problem number 3 on the backside. Problem number 4 on the backside. Remember guys, these problems do take time. There is quite a bit of writing. Just watch your negatives, watch your variables, and you know, if you go slow and you check your work, you should be okay. Best of luck to you. Hopefully you don't have this much writing, but it does seem like that at times. And thank you for watching my video. Good luck in solving, and I will see you in class tomorrow. Bye.